And then, so let me demonstrate here. So every two people has a mirror. So you put the mirror on the line. And then you come on this side, on the side where the four-sided figure is, and you look through it, and you can see a reflection of the four-sided figure on the other side. So then you're supposed to try to trace that as you look through. It's kind of tricky. So as you look through this way, you'll be able to trace the four-sided figure on the other side. You'll have to use the red thing when she's done. So see how you can see that in there? Now you have to try to look up from this side and reach your hand around and try and trace it as you're looking at it. So you gotta look this way, and then you can see the reflection of it right there. And then you're supposed to like reach over and try and trace it. Kind of tricky. Okay, so that was number one. So now flip the paper over and we're going to look at number 15. So number 15 is next. And so yesterday we learned our first type of transformation. Remember, a transformation is when you take a figure and move it somewhere. And the first type of transformation was called a translation. And that's when we took everything and moved it the same distance in the same direction. Okay, but today we're going to do a reflection. So that's why we have these, because we reflected it. So we're getting our second type of transformation called a reflection. So yesterday was translation. Today is reflection. And both of those are called transformations, because we're moving figures to a different location. Okay, so on number 15, the first thing it says, the directions are here, A, B, and C. So we're right now doing 15A, and it says connect the corresponding points from the pre-image and the image. So use your note card for that. So here is C prime, that's the image, and here's C, that's the pre-image, and they want you to connect those. So use your note card so it's a good straight line. And connect from the pre-image to the image. Sorry, the other way around. Pre-image to image. And do the same thing with A and A prime. And do the same thing with B and B prime. So that was part A, where it says connect the corresponding points from the pre-image and the image. So yesterday we had a translation, and everything moved in the same direction. And the way you check to see if everything moves in the same direction is you see if the lines have the same slant. And if the lines have the same slant to them, then they're going in the same direction. So we're going to check that today. It looks like everything's going in the same direction. But we're going to check that. And the way you check that is you measure the slant of the line. And the slant of the line is the slope of the line. Okay, so that's why B says make sure that the line segments are parallel. So right now we're working on part B. and just fit it where you can. We're going to find the slope between C prime and C. So that formula is -8 minus 3, and then 3 minus -5. So I'm just doing the slope between C prime and C. -8 minus 3, and 3 minus -5. Ooh, I think I miscounted here. 1, 2, 3, 4, 5, 6, 7. This is supposed to be -8. I'm so sorry. So this here is supposed to be -8. I had C prime labeled incorrectly. I miscounted. So sorry about that. So this number should have been a -8 down here in the denominator. Okay, so -8 minus 3 is -11. And 3 minus -8 is 11. So then that divides out to be -1. So what that means is the slant of this line is a -1 slant. And it looks like this one's the same slant, but I'm going to check. Actually, I'm going to do A prime to A. So that's -5 minus 8. And then 8 minus -5. -5 minus 8 is -13. 8 minus -5 is 13. So that divides out to -1 as well, which we thought was going to happen, right? We thought that the points were moving in the same direction or the same slant. And it turns out they are, because both of them have a slant of -1. And we could check this third one, but we're not going to take the time to do that. But it would come out to -1 as well. Okay, so yesterday, when we did a translation, everything was moving in the same direction. And same thing with a reflection. Everything's moving in the same direction. So that's a similarity between translations and reflections. Okay, now part C says find the midpoint of each segment. So now we're going to find the middle between C prime and C. We haven't done the midpoint formula since last week. So that's when you add. So it's -8 plus 3 and then divided by 2. And then 3 plus -8 divided by 2. So this is the midpoint between C and C prime. So -8 plus 3 comes out to -5. -5 divided by 2 is -2.5. And then 3 plus -8 is -5. -5 divided by 2 is -2.5. So that's at like -2.5, -2.5. So there's the middle between C prime and C. Okay, now I'm going to find the middle between A prime and A. So that's -5 plus 8 divided by 2. And 8 plus negative 5 divided by 2. So that divides out to 1.5. Thank you. And this divides out to 1.5. So now I'm going to come over here and go 1.5, 1.5. And there's my other midpoint. Okay, now here's why I'm finding the midpoints. Because then if you connect the midpoints, you get the line that this triangle was reflected across. So on number 1, the line was already drawn in for you, so you could put the mirror on top of that and then reflect it across. This time we had the image and the pre-image and the image, and we can now see that if you put the mirror on there, it'll reflect across, and that's the line of reflection. Everybody doing okay? Yeah, that's good. You could put the actual mirror on there and see if it reflects correctly. Okay, so now we're going to go back to number 2 on the paper. So flip the paper back over. And we've already got our image for number 1, right? So now number 2 says connect each point on the pre-image to the corresponding point on the image. So use your note card for that. And I'll try to draw that up here. See how I do. So they want you to connect from A to A prime, from B to B prime, from C to C prime, and then from D to D prime. So that was number 2, where it says connect each point on the pre-image to the corresponding point on the image. Here's the point on the pre-image, the regular A, the original, and then there's the A prime, the corresponding point on the image. Connect that. Okay, so then number 3 has some information in it in the first sentence. It says, in a translation, each point moves the same distance in the same direction. That was yesterday, right? Same direction and same distance. Okay, so in a translation, each point moves the same distance in the same direction. But it's saying, what about a reflection? Do the points move the same distance? So from A to A prime, did that move the same amount as B to B prime? Clearly not, right? Because this is a lot farther than that. So no, points do not move the same distance in a reflection. And then it says, how can you tell? I'm just going to say the distance from A to A prime is farther than the distance from B to B prime. No, the distance from A to A prime is farther than the distance from B to B prime. So yesterday in a translation, everything moved the same distance. But today in a reflection, that's not true. Everything is not necessarily moving the same distance. That's the point of number 3. Okay, then in number 4 it says, do the points move the same direction? So is this moving the same direction as that, moving the same direction as that? Yes, it is. Okay, so that answer is yes. And the reason you can tell is the connector lines have the same slope. The connector lines have the same slope, the same slant. And we actually found the slope on number 15 to show that they were the same direction. Okay, so now we're to number 5. Number 5 says, what does the line of reflection do to each of the segments connecting the corresponding points? So look at the line of reflection. What does it do to this line? That's what we're going for here. So we're looking at this connector line, and we want to see how it relates to this line of reflection. Any comments on that? Okay, the first thing that I notice is that it makes a 90-degree angle. So it's perpendicular. So the line of reflection and the connector lines are perpendicular. And then the other thing I notice is that this distance is equal to that distance. So that means this is the midpoint. So it goes through the midpoint. And we checked that on number 15. We found the midpoints, and then the midpoints helped us to find the line of reflection. And that's because the reflection line goes through the midpoints of the connector lines. Okay, so then number 6 says, so each pre-image and image points are the same distance from the line of reflection. And that makes sense, right? Because if you look at your reflection in the mirror, it looks like you're the same distance back in the mirror as what you are from the mirror. That's what a reflection is, right? So that's what's going on here. This distance is equal to that distance if it's perfectly reflected across. Okay, so that's what number 6 says, each pre-image and image point are the same distance from the line of reflection. And then the line of reflection is perpendicular. Bless you. To each of the line segments. And then number 8 says, is a reflection a rigid transformation? You have to remember what that means. That was one of the words from yesterday. Does anybody remember what a rigid transformation is? It's been 24 hours, I know. Yeah.
Isn't it like the same distance of the transformation, so
Same size.
same size, same shape?
Yeah, good. So a rigid transformation is where the new one is the same size and shape as the old one. So is that going on here? Is this the same size and shape as the original one? Yeah, it is. So this is a rigid transformation also. So yes, the image is the same size and shape. Remember, the fancy word for that is congruent. As the pre-image. The image is the same size and shape as the pre-image.